The I-630 West to I-430 South off-ramp demonstrates structural engineering concepts. We are going to specifically analyze the first girder from bent 3 to bent 5. We can simplify this structure by analyzing the girder as a continuous beam with pin connections at points A, B, and C. The self-weight of the girder and the concrete bridge deck is demonstrated by a uniformly distributed load of 1.5 kips per foot. By visual analysis, we can classify our structure to be statically indeterminate. We're going to utilize the stiffness method in order to identify the values of the support reactions. The stiffness method begins with the identification of the degrees of freedom. Recall that a degree of freedom is considered as any unrestrained displacement at a joint. Second, we will determine support reactions on the restrained structure with the applied loads. Third, determine support reactions on restrained structure with a unit displacement at each degree of freedom. 4. Form equilibrium equations for the support reactions corresponding to the degrees of freedom and solve for the displacement. Lastly, we'll create the free body diagram of the structure by superposition. The goal of the stiffness method is to restrain the degrees of freedom. Restraining the degrees of freedom makes the structure kinematically determinate. We restrain the structure by applying fixed supports at the locations of our degrees of freedom. The pin connections allow for rotation at all of our supports. For a uniformly distributed beam, we will have end moment reactions equal to WL squared over 12 and end moment shear reactions equal to WL over 2. Plugging in our values, we obtain the following end moment and shear reactions. Removing the applied loads and applying a unit rotation at each degree of freedom allows us to analyze the end moment and shear reactions. Paying attention to units, we must convert the modulus of elasticity E and our moment of inertia I from inches to feet. By summing the moments at each degree of freedom, we are able to develop a system of equations. We begin by summing the moments about degree of freedom A and set this equation equal to 0. We will repeat this so that we develop two more equations for each degree of freedom B and degree of freedom C. We can solve our system of equations by use of matrices. Please note that the matrix is symmetric. Solving the system, we are able to solve for our displacements at the degrees of freedom. By substituting the displacements theta A, theta B, and theta C back into our moment equations, we are able to solve for the support reactions A sub y, B sub y, and C sub y on our real structure. We have just solved a continuous, indeterminate beam with an applied uniformly distributed load by use of the stiffness method.